I'm Bob from Hauptwerk Hardware, and in this video we're going to take a look at this. It's the Hauptwerk Hardware System 1 bus keyboard interface, and as its name suggests, it's for wiring up keyboards which are connected in a bus type arrangement. So let's get this on the bench and take a look at it and see what it can do and how we use it. So let's take a closer look at this interface and see how we can use it. So first of all, it's got the normal two RJ45 sockets on the left hand side here. The top one goes off via a standard Ethernet type cable, Cat5 type cable, to our main control board, and the second one goes to the next one of these. So if you've got more than one keyboard, then obviously you'll have more than one of these, and you can just daisy chain them together, and that's how that would work. So that takes care of those two sockets. Then along the bottom here we've got all of these solder pads, and they're actually labelled C1, C#1, D1 and so on, so they're labelled with the note names all the way along until we get to the top one here, which is C6. And then there are three extra ones marked X1, X2 and X3, and they're just there in case you've got some extra switches or something that you want to use for whatever reason. You might have like a couple of switches or pistons or something. Obviously if you've got 8 or 9 pistons for each keyboard, then this wouldn't be enough and you'd use a piston interface anyway, but these are just here to give you a little bit of extra sort of flexibility with it really. And then you've got a pad at each end. There's one there and one there, both of which are marked organ ground. So hopefully fairly obviously they would connect to the negative side of the organ power supply, and therefore the ground connection into the organ. So the way this works is that when you press a key, your common bus in an organ is usually connected to the positive side of the power supply, certainly in a pipe organ, because you can use this alongside the workings of a regular pipe organ with an electric action. So in that type of arrangement, you've got the single bus along the back of the keyboard, you've got all of the keys with one wire coming from each key, and all you need to do is tap off of those wires and connect them to the relevant note names along here. And this will work just fine with any input voltage on these between about 5 volts and 100 volts. So whatever the voltage of your pipe organ is, it would be very unusual if it was more than 100 volts. But if it is, there's another version of this which you can order on special order, but we'll come to that later. But all we need to do really is we have a common bus along the back of the keyboard, and every key's wire connects to one of these. So if it's a 61 note keyboard, there'll be 61 wires, and hence there are 61 inputs. So that's really simple to do, and that's all you need to do really. So I'm going to take a look at the keyboard now. We'll have a look at a single bus keyboard from an old pipe organ, and I'll show you how this connects up, and we'll take a look at the MIDI output that it produces. Just before I get onto that though, I just want to mention very quickly this polarity jumper down on the left hand side here. At the top it says polarity, hopefully you can see that. And then underneath it says active and low and high. So the left position is low and the right position is high. So electrically speaking, low means off or 0 volts, and high means whatever voltage your organ's running on. If you were building this into a brand new organ with brand new switch contacts and everything, then it would be 5 volts. Because everything runs at 5 volts nowadays computer wise, that'd be just fine. But if it's an old existing organ, as we said, anything between 5 and 100 volts. But what this is for is that if it's in the right hand position, which is the high position, what it means is that when one of these key pads, one of these inputs goes high, it will see that as that the key is pressed and the note is on. So that's the normal way that this would work. This position, this jumper would always be in that position. However, there are cases, I've only come across one, and that was on a making organ, but there are cases where the keyboard actually works backwards, meaning that when none of the keys are pressed, all of the wires have got volts on them. When you press a key, the wire coming from that key goes from high to low, so it goes from plus, let's say you've got 20 volts in your pipe organ, it would be sitting at, all the keys would be sitting at 20 volts. When you press a key, it would drop down to 0 volts, which obviously if you just connected it to this in the normal way, it would mean that all the notes were playing except the ones that you press. Which would be very noisy, and it would probably not sound very nice either. So that's what this is for. So you can just literally, you lift that off of there and you pop it into the other position. So now this expects all of these to be high, and when you press the key they go low, it will see that low as note on, it will see high as note off. It also means if you put it in that position by mistake, in the normal fashion, all your notes are going to be on and you're going to deafen yourself. So that stays in the right hand position, unless you've got a special case for it not to be. So let's move on now and take a look at the keyboard itself. This is the keyboard which I'm going to use to demonstrate the single bus interface here. It's actually from the pipe organ that we started taking apart some years ago, only to find that most of the insides were unusable. But I kept one of the keyboards, and this is it, and it is wired in a bus arrangement, but it's quite interesting to look at how they've done it. So it's a standard 5-octave +1 key keyboard. Obviously they're wooden keys, and let's take a look at how they've done the actual key contacts. So the key contacts are along the back here. These little bits, metal bits, are the actual the wipers, if you like, that make the contacts connect. So what I'm going to do is I'm going to turn the keyboard round and we'll zoom right in and we'll have a look at how this works. This red wire on the right here, this connects to the actual bus, which in this is actually a bus bar. In other words, a single lump of metal that runs all the way down. But interestingly, it's not connected to the actual key contacts anywhere. So it's interesting to see how this works. So let me turn the keyboard round and we'll go from there. Here's a closer look from underneath at how this keyboard works. So this is our red wire for our single bus, and that's connected here, simply screwed onto this. And then there's a thick piece of copper which comes down, and then that's soldered to this long copper strip which runs the entire length of the keyboard, and that is what forms our single bus. But how does this connection make contact with these switches? Because you can see that all these wires have been cut off, but you can see where they would have been, and none of them connect back to this at all. So normally these contacts, I think they've got what, 1, 2, 3, 4, 5. So these have got 6 little wires that run out of the back of them. And if I zoom the camera in, hopefully you'll be able to see. I mean, they're in a whoops. There we go. They're in a terrible state, as if it's going to stay focused. But we're looking down here. It's focusing my hand. Hang on a sec. Let's see if I can sort this focus out, and I will be back. Okay, so that's fixed the focus. Anyway, back to where we were. So we're looking in here at these little wires, and you can see that every one of these switches has got 6 of these wires. Now ordinarily what would be done is that 1 or 2 of those wires would be connected to the common bus, in other words this bit down here, but normally it would be done with a wire along the top of these switches which connects 1 or 2 of those contacts to the bus, and then the other side, in other words the other 2 or 3 contacts, would be connected back from each switch to a separate wire which goes down to the encoder. So that when you press the switch, this little metal tang here, so if I can, don't know if I can actually make one of these move, hang on a sec, yeah, there we are. So I'm pressing a key now, and you can see how the little metal part here is pushed up into contact with those little wires, and so it makes contact between all 6 wires and itself. So ordinarily, if a couple of those wires were connected to our common bus red wire, this one here that runs all along bottom, and then the other couple of wires were connected to the encoder, when you press a key and it moves this metal piece in contact with those wires and connects them together, then that makes a circuit. But in this keyboard, this is not the case. And this is actually quite interesting because this has caught a number of people out when they've been wiring up their own projects, particularly with the universal encoder, because they've had strange results and not been able to understand why until we've taken a close look at the keyboard and found out what they've done. So I have connected, let me just zoom this camera back out and reposition it, so one moment. Okay, so for this octave here, this is the third octave in. I've just soldered some wires, one to each, one of the contacts from each of these switches, which I'm going to obviously connect down onto our bus encoder, our bus interface, System 1 bus interface board, so that we can see this working. But that's all I've done. I've only done one octave. There's not really much point in doing the whole thing because it's all the same, just times 5 really. But as we said, we've got our single bus under here. So let's flip this keyboard back over and see exactly how that works. Okay, so I've got the keyboard right side up again, as it were. So these are the wires from our one octave that we were talking about and our single bus wire. And we've got our contact arrangements along the back here, but as we said, there are no key contacts connected to our common bus. So let's take a closer look at how that works. So if I just zoom the camera in, okay, so now we can see that we've got each of our contacts here. So each of these set of 6 wires is one switch, and this metal part behind it is the wiper, if you like, that goes to that switch. So when we press that, that moves up and it touches all 6 of those wires. Okay, in the case of that one, it doesn't look like it actually does anymore, which is why we didn't bother with this keyboard. But I think you can see with that one. So if you look at the end wire here, you can see that it just moves just barely as that touches the wires. So that's how the contacts are made. Now, each one of these contacts, or each key if you like, is held in its up position by the tension on these springs, and these springs they just pop out from there. So now if you press the key, it will stay down, so there's nothing to bring that key back up. So we put that under there and that brings the key up. And the way that this works is that each one of these little hoops or loops, whatever you want to call them, that pop up between the keys, the other end of these is soldered to that common bus bar. So you remember when we looked at it just now that it's a long copper bar and it's got lots of blobs of solder all the way along it, and those blobs of solder are the bottom end of these little hoops. Okay, so from that hoop, this is a metal spring. So the metal spring obviously makes contact with this hoop, and the other end of this metal spring is screwed to this metal wiper, and this metal wiper is what moves upwards and makes contact with the switches. So that's how that works. So by connecting power to our red lead that goes to the common bus along the bottom, that's really connecting power to every one of these metal wipers all the way along the keyboard, so that when we press the key, it's connecting that to each one of these switches, which is all jolly good and works fine for a bus keyboard arrangement. It doesn't work fine, however, if you're using some kind of matrix arrangement like in the universal encoder or the Tutty encoder. So that's the bit where you have to rewire these switches, or you have to rewire the keyboard so that you have diodes on each switch and they're arranged in groups. And that all goes wrong because what happens is when you press a couple of keys together, obviously, if you wouldn't, but if we were to press these 2 keys at the same time, then all of the connections on this switch are connected to the connections on this switch, which works fine in the first octave, but as soon as you span different octaves or different groups of a matrix arrangement, then the whole thing goes terminally wrong. So that's caught people out. If you're going to use one of these keyboards in a matrix fashion, have a look underneath, see if it has got some way that all of these are connected together. And even more confusingly, on one particular keyboard we did for a customer, that common bus was embedded between two layers of wood in the actual key bed, so you couldn't even see it. You didn't know it was there. So it was only by measuring along these hoops with a meter that we found that they were actually connected together. If you do have that problem, by the way, don't worry, you don't have to rip the whole keyboard apart. All you need to do is you take one of these and you slip some heat shrink sleeving over it and you shrink it on so that when it goes back, it's no longer connected to this hoop. So that isolates each key. But that's not relevant to this at all. Just a bit of information that might make life easier if you're doing more than one of these. But that's how this keyboard works. So I'm going to get this connected up now to the bus keyboard interface. I'm going to put some power on our common bus and we'll see the thing working. I've got the bus interface connected now to this keyboard. I've only connected one octave of it just so that we can see what's going on here. So that's what those white wires are between the back of the blue board and the keyboard in the distance. And on the right hand side there I've got the red cable that comes down forward that's plugged into the RJ45 socket on the interface that goes back to the System 1 control board. And then we've got the keyboard itself there and the red wire in the distance, which I'll try and point at. So that's this one over here, and that is our power supply to the bus, the common bus that runs along the back of all the keys. So that is currently set to 5 volts, and if I zoom out a little bit so we can see the whole thing here and just try and lock the camera in this position, let's take a little look at what happens when we press the keys. So if we look at the computer screen now and I come across to the keyboard, if I press the bottom C on the keyboard, we get a note on and note off as we would expect, and then C sharp. Kind of the second or third time I press it, but we get a whole bunch of them. Then D, D sharp E, and so on. And then when we get further up the keyboard, I work my way along. F sharp doesn't work, but I think that's a dead key actually. G, G sharp A, B flat, and then top C. That kind of works. So the problem with that is that we're getting, certainly on the D, lots of notes on offs when we press it. D sharp seems okay. Again with E, that's a bit intermittent. I'm pressing that now, as you can probably see, and sometimes we get notes from it, sometimes we don't. And the problem with it, what's causing that to happen, is that the contacts on the back of this thing here are all dirty, they're all old. And that's causing us a bit of a problem. So that's with it running at 5 volts. Now if we increase that voltage to say 30 volts or 50 volts, then there's a very good chance that that's going to solve a lot of those problems. The only other way really to do that is to start cleaning all of these little wire contacts, which I did in one of the earlier videos, and you can see what a lot of work that is. So let's turn the voltage up now to 30 volts and we'll clear the computer screen and we'll see how it performs then. So that's with the power supply set to 5 volts. If I wind this right up now though, say to 30 volts, we'll be able to see the difference that makes. Okay, so I've turned the voltage up to 30 volts. Let's try the same experiment again and see what happens now. So that's the bottom C, note on, note off. C sharp, note on, note off. D, note on, note off. D sharp, note on, note off. E, F, F sharp we said was a dead key. G, just the single operations that's showing up on the computer screen. G sharp, A, B flat, and C. So you can see straight away that we've got a much more reliable sort of output from this old keyboard now, just by increasing the voltage, and that's with the voltage set at 30 volts, which is actually the highest that this power supply can go. Now if there's still any intermittent stuff going on, you could increase the voltage even higher, because this board is quite happily will quite happily run up to 100 volts. And by special order, if you want, we can supply them that will work at an even higher voltage. And there's no point in ordering one that's going to run at above 100 volts if you're not going to use it at that though, because if we make them to work with the much higher voltage, then they'll be much less reliable at the lower voltages. So this is a kind of good overall range. I think this one works happily from 5 volts through to 100 volts, and as I say, you can go higher. So if you're using this with a pipe organ, you can just tap off the back of the keyboard, or usually this would all be wired in a big loom, and so it would be easier to tap off at the other end where there's usually a whole bunch of connections, the other end of these wires basically, that you can connect to there. So that was just wanted to show really how the voltage affects how these old key contacts work. If you've got brand new keyboards with brand new contacts, it'll be absolutely fine at 5 volts, no problem at all. But this keyboard is this was from a pipe organ which was made, I believe, in about 1962, and this keyboard has been kicking around ever since we dismantled that organ. And that is actually the organ that was in the pipe organ part 1 video that I made quite some time ago, and we never got round to part 2 or onwards because everything inside the organ was just in such bad condition that it wasn't really reusable, and this keyboard is one of those relics. So I think that just about covers everything for the System 1 bus interface board. I hope it was helpful, and I hope that there's 1 or 2 tips in there for you as well, and that you find it nice and easy to use along with the rest of our System 1 products. So thanks for watching, and I'll see you in the next video.